So let's see how it's going to go. So when we are asked to find the area of a triangle, what we need to do is to first form two vectors that are consecutive in that triangle. So here, for instance, we can have the vector AB, which is obtained by subtracting the coordinates of A from the coordinates of B. So that's 1 minus 0, 1 minus 1, 1 minus 0. So that's 1, 0, 1. Then you have AC, and make sure you read the proper vectors. A is here, C is there, so that's 0, minus 0, 2, minus 1, 1 minus 0. So that's 0, 1, 1. So these are the vectors AB and AC, and the area is 1/2 of the magnitude of AB cross AC, because it's a triangle. If it was a rectangle, that would just be the magnitude of the cross product. And so we are going to do that 1/2 magnitude of, and we do this cross product. We don't cross product three things. It's two things, two vectors, AB and AC. That's AB, that's AC. The way we do the cross product is right there. We cover the first column and do the product and subtract. So that's going to be 0 minus 1, then minus, cover the second 1 minus 0. And then the third one, you cover the last, you get 1 minus 0. So this is 1/2 of the magnitude of -1, -1, 1. That's square root of 3/2. In the second question, you were asked to find the vector projection of the vector V onto U. Of V onto U. And then it's given V equals -1, 1, 2, U equals 2, 0, 3. In order to answer the question, you need to know what is being projected onto what. And that's what testing is about. We are projecting V onto U, so the vector that has to remain is U. And so, yeah, that this is V dot U over U dot U times the vector U, because we are projecting onto U. So the thing that is below there is the magnitude of the thing that we are projecting on, which is U. And that is equal. U dot V here, it's -2 plus 0 plus 6 over U dot U, that's 4 plus 0 plus 3. And then U is 2, 0, 3. And this is -2 plus 6, 4 sevenths. So 4 sevenths times 2, that's 8 sevenths, 0, and then 12 sevenths. That's it. In question number 3, you were asked to find the length of the curve r of t equals t sine t plus cosine t. This exact problem was solved twice during the lectures. T cosine t minus sine t, and then t squared for 0 less than t less than 3. And the answer is the length is the integral from 0 to 3 magnitude of r prime of t dt. And so you need to find r prime of t. And that's the product rule on this. It's going to be sine t plus t cosine t minus sine t, derivative of that. Then cosine t minus t sine t minus cosine t. And then derivative of t squared is 2t. And then sine t cancels with that. Cosine t cancels. So r prime is t cosine t minus t sine t and 2t. And so you get the magnitude of r prime of t. Magnitude of r prime of t is equal to square root of t squared cosine squared t plus t squared sine squared t plus 4t squared. And so you can get t squared cosine t plus t squared sine t. This is t squared plus 4t squared, that's 5t squared, square root, that's t squared. So that's the length of the curve. In question number 4, we're asked to find the velocity given the acceleration. So a of t equals cosine t, sine t, and negative sine t and t. Find v of t, knowing that v0 equal 1 minus 1, 2. Simple application of the formula. V of t is v0 plus integral from 0 to t a of s ds. That's what we do. And v0 is 1, negative 1, 2, plus integral 0 to t cosine of s, negative sine of s, and s ds. So you integrate each of them and you add. That is 1 plus, and this is sine s. Plug in 0 and then plug in t. minus 1 plus cosine of s, plug in 0, then plug in t, s squared over 2, plug in 0, then plug in t. When you do that, you get v of t equal 1 plus sine t minus sine of 0, that's 0, minus 1 plus cosine of t minus cosine of 0, and cosine of 0 is 1, and then t squared over 2. That's why you get v of t equals 1 plus sine t cosine t, t squared over 2. And there's no alternative answer. That's what question number 4 is. Any questions? Any questions on the 4 problems we have solved till now?
Yes, sir.
Now the question number 5. Question number 5 said you have a vector position and we need to find the velocity, the speed, and the acceleration. That's 3 different things. So v of t equals, and so not v of t, but r of t equals e to the 2t negative sine t and t. Find v of t, magnitude of v of t, and a of t. And so here, v of t is the derivative of r prime of r of t, so that's r prime of t. Derivative of e to the 2t, it's 2e to the 2t. Derivative of negative sine is negative cosine, and derivative of t is 1. A of t is the derivative of r prime of t, so that's 4e to the 2t. Derivative of negative cosine t is sine t, derivative of 1 is 0. So that's the acceleration, that's the velocity, and the speed is the magnitude of v of t square root of 4e to the 4t plus cosine squared t plus 1. That's it, nothing else required. Question number 6 was find the tangential and the normal components of the acceleration. And you have r of t given to you as t cosine t sine t. That's also one of the problems that was solved during the class. Exact same problem. Find AT and AM. What's the formula that we use to find AT?
A dot T.
A dot T. So start by that. You have that formula, so you know you need A and you need T. And for that, you need to find A and T. So R prime of T is 1 negative sine T cosine T. That's V of T. R double prime of T is 0 negative cosine T negative sine T, and this is A of T. And magnitude of R prime of T is square root of 1 plus cosine squared T plus sine squared T. This is root 2. So that tells us that T equals R prime over magnitude of R prime equals 1 over root 2 negative sine T over root 2 cosine T over root 2. So that's T, and the A is on top. So here we have A dot T equals 0 times 1 over root 2 minus cosine T times minus sine T over root 2 plus are we good here? So we're doing A dot T, so that is this times that. So minus and minus that you have here, and then this one negative sine T times cosine T over root 2. And then you see that here we get cosine T sine T over root 2 minus sine T cosine T over root 2, and this is 0. So AT is 0. Questions? So what's the formula that we use for AN? And again, remember that AT and AN are numbers, are scalars. They are not vectors. So you can't give the answer as a vector. You can't have a dot product that is equal to a vector. Now, what formula do we use for AN?
A cross V over magnitude of V.
Right there, you have the mistake I just talked about. Something is missing in that answer that makes it wrong.
Magnitude of A cross B.
Magnitude of A cross B. Over?
Magnitude of B.
And so you have A and you have V. That's it. We got them already. So all you have to do is write down that magnitude, A cross V, or you could put V cross A, doesn't change anything. So we are crossing these two vectors. You can keep this, you get sine squared plus cosine squared. And if you don't multiply correctly, you get a wrong answer right there, because this is negative sine squared minus negative plus cosine squared. Then you cover this and you get minus sine t minus 0, and then the minus, it gives you sine t. Then you cover that and you get minus cosine t. You're gonna get the magnitude of that. And the magnitude of v is the magnitude of r prime, which we already found, root 2. And so the magnitude of this vector here, sine squared plus cosine squared, is 1. That's 1. So this is square root of 1 squared plus cosine squared plus sine squared t over root 2. And this is equal to 1 because sine squared plus cosine squared is 1. 1 plus 1 is 2. So root 2 over root 2 is 1. So the normal component of the acceleration is always equal to 1. And the tangential component of the acceleration is always equal to 0. This technically means that the acceleration is always normal. The acceleration is always in a direction that is orthogonal to the velocity. Problem 7. I gave you r of t, and we ask you to give the radius, the curvature, the radius of curvature, and the binomial vector. So r of t is t cosine t sine t. And you notice that it's exactly that same vector that was given in the first in the previous problem. So you don't need to do twice the same work. And the curvature, the radius of curvature, and the vector b. And again, I say, notice that this is part of question 6. So you don't have to do twice the work that you already have. And all you have to do is tell us, what's the formula for the curvature? Hello?
Magnitude of v cross a over magnitude of v cubed.
And all of that is already done up there. So you don't need to waste time. Magnitude of v cross a, that's it. It's root 2. We got that here. That's it. Magnitude of v, it's root 2. We got that up there. Cubed. So that's 1/2. The radius of convergence is 1 over that. So that's 2. No time to waste. So what is binomial vector? B equal to, what's the formula for this?
E is equal to t cross n.
T cross n. All right, so that's it. And we got t here. We got t already here. That's it. What we are missing is n. So t is 1 over root 2 negative sine t over root 2 cosine t over root 2. And we want a cross product with n. And n, we know n is t prime over the magnitude of t prime. Here it's simple. We can do that very simple. This is t. T prime will be 0. Negative sine t derivative is negative cosine t. Cosine t derivative is negative sine t. And that was over root 2 over root 2. But when we divide by the magnitude of t prime, the magnitude of that t prime, okay, all right. Now this is t prime. The magnitude of t prime, the magnitude of this vector is 1 over root 2. That's what I was saying. So we can just cancel the root 2 when we multiply. Root 2 just cancels because it is over 1 over root 2. Does that make sense? Am I making sense here?
Yes.
Because that's t prime over magnitude of t prime. And the magnitude of this t prime is 1 over root 2. So when you divide that by 1 over root 2, this just cancels. And then you need to do the cross product. And you notice one thing, that this vector, 0, negative cosine t, negative sine t is exactly the acceleration. Can you see that? That's the acceleration that we found here. And why is it okay? We didn't actually need to do all this work to find that. Because we found that the tangential component of the acceleration is 0, and the normal component of the acceleration is 1, right? Technically, this already could give us that a equals 0 times t plus 1 times n. So right there, we don't need to do any extra work to figure this out. A equals n. Just did that to show you again that we could get that for free from the previous question, that n is actually just a. And this is v over magnitude of v cross a. I'm just going to save myself some time. So that is v cross a over magnitude of v. In this specific problem, it works like that because a equals n. And so here, right here, I'm giving you actually another way of finding n if you don't want to take derivatives. If you already have the tangential components of the acceleration and the normal component, you can solve for n. And so because I already had this done here, I'm just writing this formula down to avoid having to do twice the same work, right? And that's the cross product A cross V. That's what I wrote here. And I wrote it as V cross A to take the magnitude. So V cross A is exactly what I have right there. So I don't need to do any work. I just copy that down. It's 1 sine t negative cosine t. And the magnitude is root 2. So B is 1 over root 2 sine t over root 2 negative cosine t over root 2. Questions? Is there any questions? Now you can check that b dot t is 0, b dot n is 0, and t dot n is 0 on your own if you wish. Now the next question was find t and n. So we need to find t and n in this question. So the first thing is you're going to find v of t equals 1, 1, 2 cosine t, and a of t 0, 0, minus 2 sine t. So t is v of t over magnitude of v of t. And so this is 1 over square root of magnitude of v of t is square root of 1 plus 1 plus 4 cosine squared t, which is square root of 2 plus 4 cosine squared t. So that's 1 over square root of 2 plus 4 cosine squared t, 1 over square root of 2 plus 4 cosine squared t, and then 2 cosine t over square root of 2 plus 4 cosine squared t. Now, when you look at this, you understand there is no way you're going to be wasting your entire test time to figure out n equals t prime over the magnitude of t prime. And that's why it's good to come to the lectures, because I gave you a way to answer the question in such a case without wasting your time finding derivatives. And that we had it in the previous problem. So in such a problem, what do we know? What's the normal component of the acceleration? What is AT equal to? That's a formula for AT.
A dot t.
A dot t. And that is equal, this is A, and that is t. Dot, that's 0 plus 0 minus 4, 0 plus 0 minus 4 cosine squared t over root 2 plus 4 cosine squared t. So that's the answer, negative 4 cosine squared t over root 2 plus 4 cosine squared t. What is the normal component of the acceleration? Putting this What's the alternative formula we had for this?
Magnitude of A cross B over the magnitude of B.
That's it. That's what we get. And so A cross V, we can get that here. Magnitude of this is going to be -2 sine t. Then with a minus, here you're gonna get 2 sine t. And then here you're gonna have 0. And then you're taking the magnitude of that over the magnitude of V. And the magnitude of this thing is root 4 sine squared plus 4 sine squared. So that's root 8 sine squared, which is 4 root 2 sine t. Divided by the magnitude of V, which is again root 2 plus 4 sine squared t. So we got this. And so we have A equals T times AT plus AN times N. And so you can get N as A 1 over AN A minus AT T. So that N and AN, this is this, root 2 plus 4 cosine squared t over 4 root 2 sine t times A, that's A, 0, 0, -2 sine t minus AT minus and minus, that's plus 4 cosine squared t over root 2 plus 4 cosine squared t times t, which is 1. Let me see it this way. 1, 1, 2 cosine t over square root of 2 plus 4 cosine squared t. These things cancel. Now you can do the algebra if you want. If you want, you can leave it as is. Root 2 plus 4 cosine squared t over 4 root 2 sine t. And then here, you're going to have 0 plus this. So that's be 4 cosine squared t over 2 plus 4 cosine squared t. 0 plus that, so that's 4 cosine squared t over 2 plus 4 cosine squared t. And then -2 sine plus that. Eight cosine cube of t over 2 plus 4 cosine squared t. Any questions? Now you can continue to multiply this inside there, but it's completely unnecessary. Any questions about this? Problem now when you're taking derivatives is that you have a chance of having mistakes in there by trying to take derivatives of ratios with cosines and square roots at the same time. You have a lot of chances of not getting the right answer. But here all you're doing is algebra, adding, multiply. Any questions? Okay, what question number 9 was saying? Find the intersection of the lines. S3S 5 minus 4S and R of t equals 3 minus t 1 plus t minus 1 minus t. And like we said, you set the three equations equals component wise. So S is 3 minus t, 3S is 1 plus t, and 5 minus 4S is minus 1 minus 2. So that's the system that must have a unique answer or many answers for you to say what the answer, the solution to the problem is. If you don't find a solution, then there is no intersection. You find one, then it's 1 point. If you find many, then the two lines are same. So what I suggested was take that first equation, plug it into the second, and then plug it into the third. When I plug into the second, what I get is 3 times 3 minus t equals 1 plus t. When I plug in a second, that's 5 minus 4 times 3 minus t equals minus 1 minus t. And this system of two equations must have one single answer. If I have different t's in both equations, then there is no answer. If I find out that it's true for all t, the two equations, then the two lines are same. If I don't find the same t in both equations, then there is no intersection. So here I'm going to solve that first one. So this is 3 times 3, 9 equals minus 3t goes to the other side, becomes 1 plus 4t. So it gives you t equals 2 in that first equation. And in this second, you got 5 minus 12. That's minus 7 equals 4t. 4t goes to negative t, becomes minus 5. And you have first negative 1 here, minus 5t. So negative 4 minus minus, that's plus 4, goes to the other side, becomes minus 4 minus 4 minus 1, that's minus 5t. 4 times 3 is 12, 5 minus 12 is negative 7, and then you got a minus 1 that is here. This minus 1 goes to the left, becomes minus 6. So you get here, t equals 6/5. So it's not the same t. So different values. Exact, no intersection. So the two lines don't intersect. Their intersection isn't. Any question on this problem? Now in number 10, it says write the equation of the plane that goes through a point A. And it's parallel to U equal 1, 1, 1, and V equals -2, 0, 1. And I'm going to warn you, this part of our lecture, which some of us did not consider this seriously, is what is going to take you into Calc 4 for those of you who are going to take Calc 4 as a required course. And if you don't understand vector calculus, you're going to be in trouble there. So you better take time to review these if you did not understand. It's very important. All the other things that you have done in this course, sequences, series, and so on, those are all useless in Calc 4 if you're taking Calc 4. But this last chapter is the main thing that you're taking out of this course to Calc 4. And there they are going to assume you know that. Now to answer this question here, we know that equation is going to be n dot am equals 0, where n is u cross v. So here I can find n, u cross v. That's why I wrote them this way, so I can easily find u cross v. That's 1 minus 0, then minus 1 plus 2, and then 0 plus 2. So that's n equals 1 minus 3, 2. So am, so this is going to be 1 minus 3, 2, dot am is x minus xa1, y minus 2, and z minus 1 equals 0, or in other words, 1 times x minus 1 minus 3 times y minus 2 plus 2 times z minus 1 equals 0. Or you can now write as x minus 3y plus 2z, and then minus 1 plus 6, that's 5, minus 2 plus 3 equals 0. So that's the equation. And that's it for the test. That was the last question. Any questions in general? Silence. Any other questions on this course from the beginning? Something that you didn't get at that you might want to talk about now? I'm really not used to talking in an audience where I don't see anybody and nobody answers any questions and nobody asks any questions. Doesn't look like a lecture to me when it happens like that. Now, please answer this question. That's the beginning. Then I'll give you a second question. Your answer, Matthew.
I haven't finished yet, but I got a prime of t.
A of t, v of t, not a prime.
Okay. So I got the v of t is equal to 2e to the 2t minus 1.
You get the formula first.
Okay. V of t equals a prime of t plus v0.
Hmm. Yeah. This is the starting point. Eric, what do we get next?
You get the you substitute for a instead of t, put s in there.
IV.
You do 1 minus 1 and 0 plus integral of the accelerations, and so you plug in s for the t's.
Mhm. That's it. And now what you do is the calculus that you need to do. It's 1 minus 1, 0, plus the integral of e to the 2s is e to the 2s over 2, 0 to t. And here it's e to the 2s over 2 plus s, 0 to t. And there it's sine s, 0 to t. So that gives us 1 minus 1, 0 plus 1/2 e to the 2t. Then you plug in 0. E to the 0 is 1, so that's minus 1/2. Then you get e to the 2t, 1/2 e to the 2t plus t minus, you plug in 0, you get 1/2. Then you get 0. Then sine t minus, you plug in 0, you get 0. That's how you do the work. So now you can add 1 and minus 1/2, that's 1/2 plus 1/2 e to the 2t. And then minus 1 minus 1/2, that's minus 3/2 plus t plus 1/2 e to the 2t. And then sine t minus 0 plus 0. That's it. That's how you do the work. Now, how do you find r of t? Gauge. Is Gauge here? JC?
You use the same equation, but R0 instead of V0.
So that's not the same equation. It looks like it, but it's not the same. You're integrating v. So what's R0 here?
Zero, negative 1, 1.
Okay. What's here?
The answer right above it.
Something needs to be done with it first.
Simplify it.
No. What do we do here?
Oh, change T's to S's.
T to S. Right. And then you can do the integration. Integral of 1/2 is S over 2. This is 1/4 e to 2S from 0 to S and from 0 to T. Then the second one, this is negative 3/2 S plus S squared over 2. So it's 1/4 e to 2S, 0 to T. And then the integral of sine is negative cosine S, 0 to T. Plug in T, you get T over 2 plus 1/4 e to the 2T. Then plug in 0, you get minus 1/4. And it is important to know that when you integrate, you end up plugging in the values. That's why you first switch to S, not to think after integrating that you got a function of T that you don't need to do anything else with. Plug in T, you get negative 3/2 T, T squared over 2, 1/4 e to 2T, minus, then you plug in 0, that's 0, 0, 0, but here it's not 0, it's minus 1/4. Then you plug in T, negative cosine T, minus, then you plug in 0, you get 1, minus 1, that's plus 1, so it's not 0. Now you're going to add those things. 0 plus this, so that's minus 1/4 plus T over 2 plus 1/4 e to the 2T, then minus 1 minus 1/4, so that's minus 5/4, minus 3/2 T plus T squared over 2 plus 1/4 e to the 2T, and then 1 plus 1, 2, minus cosine T. That's how you would answer this question. I'll take another 5 minutes to answer this. Find U. So this is find using Taylor series limit of sine T minus T over T cubed. Would you share your answer with us, Nick? That's probably the last question we answer today.
Yeah, I can share. So the first thing that I did was I defined the Taylor series of sine of t, which was t minus t cubed over 3 plus t to the 5th over 5 factorial.
Can you say that again?
Yeah, so the Taylor series for sine of t is t minus t cubed over 3 plus t to the 5th,
Out of it, 3.
3 factorial. Plus t to the 5th over 5 factorial, and then so on.
That's it. That'll be it for me today. Thank you. I'll see you next time.